All right, we're starting a new ID, no IDs, a new idea on page 135. Call it complex numbers. Did you know that there are numbers that aren't real, and we like to call them Z?
I thought it was I.
No, there's going to be an I in them, but the actual name of a complex number is often associated with a Z. I probably won't use that anymore this year, only I'll just give you that information. So this is the real part. So you're taking notes on page 135, and this is the imaginary part. Have we done stuff with these this year? I know you've seen them other years. What did we do?
I don't think so.
I don't think we did. I don't remember doing it. I know sometimes, well, never mind. Let's first of all learn how to graph them. So give yourself a plane, and notice I used to say give yourself a coordinate plane. It's now not called it's now the complex plane, and things work differently. Instead of having X and Y.
Oh, is this the thing with X, Y, and Z? With
Well,
this? Like,
there's
oh,
the-
I love. Oh, that was so fun.
Well, we can do 3D stuff, but not today. All right, so now we're going to take, instead of X and Y, we're going to have the reals. The real value is going to be on the X-axis, and the imaginary value is going to be on the Y. So let me give you an example, and we'll graph it. Let's graph 3 plus I. Let's give it a number. No, I's good. 3 plus I. So this is the real part. So I'm going to go out on the real axis, which was formerly the x-axis. And how many i's? It's an unwritten 1 there, which I write for convenience. And that means I go up 1. So this is the point. So draw the axis, the complex plane, and call it 3 plus I right next to it so you can remember what that means. 3 plus I is how you graph it.
Wait.
Can you try?
What's the R thing?
Real numbers.
This is the real.
Oh, I got
The reals are on here, and this is the imaginaries. All right, try if you could find this one. Graph minus 2 minus I. Try that one. So you can put it on the same coordinate plane. And you find minus 2 minus I. What quadrant? Allie, does it show up
It's in
in?
the third quadrant.
Okay, let's check her out here. So minus 2 on the reals, so we're going to go back to, and minus I on the imaginary. Very good. There it is. Mark it. Minus 2 minus I. So notice it doesn't have a comma like we used to seeing in the real plane. It's sort of just an expression. So this is the real part followed by the imaginary part. The imaginary part is hooked to the real part by the sign, the S-I-G-N. So does that look somewhat familiar from somewhere in your past? Okay. We're blazing new territory here. All right, let us look at the absolute value of a complex number. So let me give myself some room. I was wondering, I'm sure you were as well, what's the absolute value of 3 plus I? We've got that one graphed, so that's why I picked it. What is the absolute value? So you're used to seeing these symbols. So the absolute value of 3 plus I. In absolute value land, the absolute value is the distance from 0, right? So on the complex plane, it's just the distance from the origin, that's all. So if we know we went over 3 and up 1 on the complex plane, how do we get this distance?
Did you do triangle thing?
You can do the triangle thing, and that's the Pythagorize it. So we're going to do the square root of 3 squared plus 1 squared, and that comes out to be 11? No,
9
10.
plus 1, so that's
10, sorry. I can do this. All right, is that reducible, square root of
2
10?
times the square root of 5.
But that doesn't reduce it, so we'll keep it. But that's how you do check it. Very good. So this is the square root of 10. So let's make a general formula. The absolute value of a plus bi is simply the square root of, can you fill it in? for me?
A squared plus B squared.
A squared plus B squared, right? So any number I give you in any of the quadrants, you should be able to come up with its absolute value.
Is this like physics with vectors?
That sort of looks like it, because
Kinda
we
like
do,
it,
it's like the
we do that.
magnitude,
Yeah.
very much so. Good, I'd like to see those parallels. All right. Let's try one more thing and then we'll break for the day. So it's going to be a quick lesson. This other thing is learning how to write these 3 plus i's in a different form. So I need your calculators out to help me with that. I'll just teach it on the same one. So I'll need some help with it. So what do I need from here? I'm going to pick up this triangle and enlarge it right here so you can see it clearly. So all I'm doing is taking our 3, it was 3 on this side, and our 1 on that side, and removing it. And we also came up with the square root of 10. Well, this one's not going to be any fun because I already have the answers. So let me find one where I do not. Let us, well, that's all right. I think I can fudge with this one. All right. What I'm teaching now is called the trig form. I taught you the absolute value. Now I'm going to ask you to write the trig form of this number, 3 plus I. And it is always in this form, and let me explain it. Get it down. It's R, and I'll explain what R is. Cosine theta, I told you a trig would be back with us, plus I sine theta. That's going to be the trig form. Lots of times I give you a specific problem and then the formula, but now I'm doing it the opposite way. Here's the formula, and I'm going to teach you how to put this number in its trig form. So, here's a picture of it all blown up. R is this part. So, I'm going to say equals R. So, if I'm writing this in trig form, the number outside is square root of 10. Then I hit a parentheses. Then I hit the word cosine. And then I hit I sine. Notice there's a theta here and a theta here. When I get theta, it's going to be the same number here as it is here. So, all I need to know is this angle. That's why I asked you to get your calculators out. What technique have I taught you so far this year where if you know the sides, you can find the angle? Can you think of something?
Cosine equals adjacent over hypotenuse.
Adjacent over hypotenuse. And what is that
And then
function?
Cosine.
All right, cosine of the angle equals adjacent over hypotenuse. Right. So then you could use the cosine inverse button to get the angle. You could also use the cosine inverse sine if you use 3 over the square root of 10. And a lot of times in physics we use what? Inverse what? Instead of inverse cosine, instead of inverse sine, we use?
Inverse tan.
You're right, we do. Hey, you're not in physics. All right, so tan inverse is a typical way that we find theta, but the cosine works as well. So tan inverse of 1 over 3, and that's where I need your help. So tan inverse of 1 over 3, or Allie, you do cosine inverse of 3 over square root of 10. Oh, you can't? All right. All right, thank you.
Vanished.
I did both.
All right,
Yeah, I did both.
18.
they're both 18?
18.4.
Never mind, Allie, we got it. So 18 degrees goes here, and 18 degrees go there. So why do we use this big sloppy mess to write out the name of a point, which looks so nice and simple, a 3 plus I? So we're going to change it to square root of 10 cosine 18 plus I sine 18. It turns out that there are a whole bunch of things you can do with a complex number in this form that you can't. You can't do it in this form, you can in this form. You can't take the square root of a complex number in this form, you can't square it. And so here you can. So we're kind of building towards something. So let me give you one while I go wash my hands. And let's see how you are at changing it to trig form. So I'll leave this up here. Here's the one that I want you to do. And once, I think it's probably been about 10 minutes. Let me put it up for her and then we'll just close it down. So Abby, give this one a try and see if you can get it to look like this, the trig form. So, see you later. All right.